Welcome to Maths Companion. Let us recall what we have learned in the last video. The square of a sum of two positive numbers is sum of the squares of the two numbers and twice their product, or a plus b all square is equal to a square plus 2ab plus b square. We have learned this identity in the last video and we have done some problems using this identity. There were some homeworks. Compute the squares of these numbers. First one 52, second one 105, third one 20 and half, and fourth one 10.2. Let us find the square of 52 at first. That is 52 square. 52 can be written as 50 plus 2. So this can be written as 50 plus 2 all square. That is equal to square of the first number, that is 50 square, plus 2 into first number into second number, or 2 into 50 into 2, plus square of the second number, or 2 square. 5 square is 25, therefore 50 square is 2500. 2 into 50 is 100, 100 into 2 is 200. 2 square is 4. 2500 plus 200 is 2700, plus 4 is 2704. That is 52 square is 2704. Now 105 square. 105 can be written as 100 plus 5. So this can be written as 100 plus 5 all square. And this is equal to 100 square plus 2 into 100 into 5 plus 5 square. There are two zeros in 100. Therefore, there must be 4 zeros in the square of 100. That is 1 and 4 zeros, or 10,000. 2 into 5 is 10. 10 into 100 is 1000. 5 square is 25. 10,000 plus 1000 is 11,000. Plus 25 is 11,025. That is 105 whole square is equal to 11,025. Third part, 20 and half whole square. 20 and half can be written as 20 plus half. So this can be written as 20 plus half whole square. And that is equal to first number square, that is 20 square, plus 2 into first number into second number, or 2 into 20 into half, plus square of the second number, or half square. 20 square is 400. 2 into 1 by 2 is 1. 1 into 20 is 20. 1 by 2 whole square is 1 square by 2 square, or 1 by 4. 400 plus 20 is 420, plus 1 by 4 is 420 and 1 by 4. Now 10.2 square. 10.2 can be written as 10 plus 0.2. Therefore, this can be written as 10 plus 0.2 all square. And that is equal to 10 square plus 2 into 10 into 0.2 plus 0.2 square. 10 square is 100. 10 into 0.2 is 2. 2 into 2 is 4. There is one digit after the decimal point in 0.2. Therefore, there must be two digits after the decimal point in the square. 2 square is 4 and therefore 0.2 square is 0.04. 100 plus 4 is 104 plus 0.04 is 100.04. Today let us do the problems on page 74. First problem. Is there a general method to compute the squares of numbers like 1 and a half, 2 and a half, 3 and a half, etc.? Explain it using algebra. 1 and a half means 1 plus half. 2 and a half means 2 plus half. 3 and a half means 3 plus half. So generally we can take x plus half. Let the number be x plus half. Now let us find the square of x plus half. This is x square plus 2 into x into 1 by 2 plus 1 by 2 all square. This can be written as x square plus 2 into 1 by 2 is 1. 1 into x is x. 1 by 2 all square is 1 square by 2 square, or 1 by 4. Now let us take x square plus x. X square can be written as x into x, and x can be written as x into 1. You can see x is a common factor in both the terms. So x can be taken outside and we can write this as x into x plus 1. So this can be written as x into x plus 1 plus 1 by 4. What does it mean? X is the number part and half is the fractional part. Take the number part. X plus 1 means the next number. multiply it by the next number and add 1 by 4 to it. That means if you take 1 by 2 square, the number part is 1. What is the next number? 2. Multiply it by 2 and add 1 by 4 to it. That is 1 into 2 is 2. 2 plus 1 by 4 is 2 1 by 4. Now if you take 2 1 by 2 whole square, the number part is 2. Multiply by the next number, that is by 3, we get 6. And add 1 by 4 to it, we get 6 1 by 4. Now if you take 3 1 by 2 whole square, the number part is 3. Multiply it by the next number, that is by 4, we get 12. And add 1 by 4 to it, we get 12 1 by 4. Second problem. Given below is a method to calculate 37 square. 3 square equal to 9. 9 into 100 is 900. 2 into 3 into 7 equal to 42. 42 into 10 is 420. 7 square equal to 49. And 37 square is equal to 1369. Check this for some more 2-digit numbers. Explain why this is correct using algebra. Let us understand the method at first. 3 is the tens digit. So first of all, the square of the tens digit is found and it is multiplied by 100. Now 3 and 7 are the 2 digits. They are multiplied and it is doubled. We got 42 and it is multiplied by 10. 7 is the unit digit. Its square is found. And these are all added together to get the square of 37. Let us do the first part. Let us take some other number and do like this. Let me take 28. First of all, we have to take the tens digit and we have to find the square. Then we have to multiply it by 100. 2 square is 4. 4 into 100 is 400. Now multiply the 2 digits and double it. That is 2 into 2 into 8. We get 32 and multiply it by 10. We get 320. Now take the unit digit and square it. 8 square is 64. Now add all these together to get the square of 28. 400 plus 320 is 720. 720 plus 64 is 784. Therefore 28 square is equal to 784. Now let us check it using algebra. Any 2-digit number can be written in the form 10a plus b, where a is the tens digit and b is the unit digit. Let us find the square of 10a plus b. 10a plus b whole square is equal to 10a square plus 2 into 10a into b plus b square. Now 10a square is 100a square. This can be written as 2ab into 10 or 10 into 2ab plus b square. What does it mean? A square is the square of the tens digit and it is multiplied by 100. 2ab is 2 into tens digit into unit digit and it is multiplied by 10. B square is square of the unit digit. All these are added together to get the square of 10a plus b. That is why the method is correct. Third part of the problem. Find an easy method to compute the squares of number ending in 5. Actually, I forgot to write this problem while writing the second problem. Which are the numbers ending in 5? 15, 25, 35, etc. 15 can be written as 10 plus 5. 25 can be written as 20 plus 5. 35 can be written as 30 plus 5. 105 can be written as 100 plus 5. So all these numbers can be written as 10 into a number plus 5. 15 is 10 into 1 plus 5. 25 is 10 into 2 plus 5. 35 is 10 into 3 plus 5. 105 is 10 into 10 plus 5. 155 is 10 into 15 plus 5. So generally we can say numbers ending in 5 can be written as 10a plus 5, where a is a number. In 15 a is 1, in 25 a is 2, in 35 a is 3, in 155 a is 15. Now let us find the square of 10a plus 5. 10a plus 5 whole square is equal to 10a square plus 2 into 10a into 5 plus 5 square. Now what is 10a whole square? It is 100a square. 2 into 5 is 10. 10 into 10a is 100a. 5 square is 25. Now 100a square means 100a into a. 100a means 100a into 1. We can see 100a is a common factor, and taking 100a outside, we can write 100a into a plus 1, then plus this 25. Whenever we multiply a number by 100, the last two digits are zeros, and if you add 25 to that number, the two zeros will be replaced by 25. So we can understand one thing, that the last two digits of the square of any number ending in 5 are always 2 and 5. Now what about the remaining part, that is a into a plus 1. If you take 15, a is 1, or let us make 15 into two parts. 5 is a part and the remaining digits are another part. Here the remaining digits is only 1. Now look at the remaining digit 1. Multiply it by the next number, that is 2. 1 into 2 is 2. Then put 25. That is 15 square is 225. Now if you take 65 square, first of all let us make two parts. 5 is a part and the remaining digits together is another part. That is 6 is the second part. Now look at the second part, 6 at first. Multiply it by the next digit, that is 7. 6 into 7 is 42. Then put 25. Now if you want to find 105 square, 5 is a part, 10 is another part. 10 into next number is 10 into 11 or 110, and put 25 to it. So 105 square is equal to 11,025. Next problem. Look at this pattern. 1 square plus 4 into 2 equal to 3 square. 2 square plus 4 into 3 is 4 square. 3 square plus 4 into 4 equal to 5 square. Write the next two lines. Explain the general principle using algebra. First of all, let us write the next two lines. 4 is common in all lines. In the first line, you can see three consecutive numbers 1, 2 and 3. In the second line, there are next three consecutive numbers 2, 3 and 4. And in the third line, there are three consecutive numbers 3, 4 and 5. And therefore, in the next line, we have to write the three consecutive numbers 4, 5 and 6. That is 4 square plus 4 into 5 equal to 6 square. And in the next line, we have to take the three consecutive numbers 5, 6 and 7. 5 square plus 4 into 6 equal to 7 square. Now we have to explain the general principle using algebra. In all the lines, there are three consecutive numbers. Let us take the three consecutive numbers as x, x plus 1 and x plus 2. Let us take x plus 2 all square, that is equal to x square plus 2 into x into 2 plus 2 square. 2 into 2 is 4, 4 into x is 4x and 2 square is 4. So this can be written as x square plus 4x plus 4. Now look at 4x plus 4. 4x can be written as 4 into x and 4 can be written as 4 into 1. So 4 is a common factor. Taking 4 outside, we can write this as 4 into x plus 1. So this can be written as x square plus 4 into x plus 1. That is x plus 2 all square is equal to x square plus 4 into x plus 1, or x square plus 4 into x plus 1 equal to x plus 2 all square. When x is 1, x plus 1 is 2 and x plus 2 is 3. Then we get 1 square plus 4 into 2 equal to 3 square. When x is 2, x plus 1 is 3 and x plus 2 is 4. Then we get 2 square plus 4 into 3 equal to 4 square. When x is 3, x plus 1 is 4 and x plus 2 is 5. Then we get 3 square plus 4 into 4 equal to 5 square. Today we have done some problems on page 74. Now there are some homeworks. First one, explain using algebra the fact that the square of any natural number which is not a multiple of 3 leaves remainder 1 on division by 3. Next problem, prove that for any natural number ending in 3, its square ends in 9. What about numbers ending in 5 and numbers ending in 4? We shall discuss the remaining part in the next video. Till then, bye.